Hello, my name is John Kelly and this is the Weber Auto YouTube channel. Today I'm going to show you how to use the new NVH smartphone and tablet app to diagnose vibrations on vehicles. I have a previous video where I showed you how to go on a road test and determine what type of vibration the vehicle has. And there are three types or groups of vibrations that a vehicle can have. One of them is tire speed related vibrations, which is everything that spins the same speed as the tires, of which there's a lot of things that do that. Another one is drive shaft speed related vibrations. Drive shaft or propeller shaft, same thing on rear wheel drive and four wheel drive vehicles. And then we also have the third group is engine speed related vibrations, and I will show you how to diagnose those also using this app right here in your stall of your shop. But you should have first gone on a vehicle road test, and like I said, there's a separate video I've produced that shows how to road test with the new NVH app. So I'm going to start with engine speed related vibrations. I've got a 2015 Ford Explorer right here, and I am going to show you what is normal on engine vibrations and what would be abnormal, and how to tell if the normal vibrations that all engines have are being transferred into the passenger compartment to where the driver of the vehicle might be feeling it. So to do that, I am going to use an optional, you do not have to have this, but it's optional. It's a Bluetooth data link connector adapter. It's part number BT1A from GoPoint Technologies, and their website is GoPointTech. That's GoPointTech.com, and you can purchase a BT1A Bluetooth data link adapter. This one works with Apple and with Android devices, and as I said, we'll have an Android version of this app out later this summer. But what this Bluetooth interface does is it allows us to just plug into the vehicle, communicate with the engine control module, and get the exact engine RPM. And if you're diagnosing an engine speed related vibration, if that's what you determined you had on your vehicle road test, then I would recommend that you get one of these. Current NVH app customers, there's a discount code in the app where you can get a discount off the cost of one of these off the website. So we are going to plug this in now and start the engine and just let it idle, and we'll take a look at a few things about normal engine vibrations. All right. With the app, of course, we have to tell the app what vehicle we are diagnosing. And so I'm going to select pick my vehicle, or pick your vehicle in the app. This is a Ford, so I will scroll down to Ford 2015 Explorer, and we will add more model years. We're adding more model years and more vehicles every week to this app. But this is an all-wheel drive 3.5 liter engine. So that's the very top option here. And the app already knows this is a 6-cylinder engine. It already knows what the front axle gear ratio is, what the rear axle gear ratio is. This is a crossover all-wheel drive vehicle. The only thing it does not know is what size tires are currently on this vehicle. So we have to punch in the tire size. These have a 255/50 R20 tire. And once we've punched in that tire size, all we have to do is hit start, and it takes us to the vehicle view screen. I want you to notice that with me just sitting here holding the smartphone, there are no parts glowing red on the vehicle view screen. And if you recall from the previous two videos I've done on this app, whenever the app detects a vibration, those parts will glow red on the screen. So obviously I'm not vibrating. I'm going to set this on the radiator support of the vehicle here and see if it detects any vibrations. And if it detects any vibrations, it will glow red. Now there is a sensitivity level adjustment in the settings. By default, we've got it on a medium sensitivity level, and you can turn that up or turn it down. Now notice, of course, it's not picking up any vibrations at all. Nothing is glowing red, but watch what happens when I set it on the engine. By the way, I have a cord connected to the iPhone so that I can record the screen as we go here. But I want you to notice, as soon as I set it on the engine cover, the engine starts glowing red in the NVH app, and that means that it is detecting an engine speed related vibration. Now there are several different types of engine speed related vibrations, and this app gives us 3 different ways to view which type of vibration we have. So we are looking at vehicle view first, which just tells us you have an engine speed vibration. The next item is the live graph. So on the bottom center of the screen, if we click the live graph icon, now it'll show us a bar graph of amplitude levels for the different types of vibrations that are on this vehicle. Notice the E3, engine third order vibration. That means there are 3 shakes per revolution of the crankshaft. This is a V6 engine. So on a V6 engine, there are 3 pistons on the power stroke per revolution of the crankshaft, and it's absolutely normal on an engine to have, on a V6 engine, to have 3 shakes per revolution, those pulses from the power stroke of the engine. But if I bring that smartphone back over here to the radiator support, it's gone. Now why is it gone? Well, it's gone because the engine motor mounts, the transmission mounts, the exhaust mounts, the body mounts, all of the mounts are doing their job. They're responding as they should to dampen the amplitude levels of those normal engine vibrations. If you ever had a vibration that did not change when you went from the engine to a fender or radiator support or the driver's seat, the steering wheel, the floor, or the dash, then that means that there's a transfer path issue between the engine and wherever the vibration is being detected or felt by the driver of the vehicle. So that's a pretty cool way of isolating whether or not you've got bad motor mounts, transmission mounts, exhaust mounts, etc. Now there's another view. If I set this back on the engine, we can go to the live data tab, and the live data tab will give us the vibration frequencies or RPM. Right now the app is in the RPM mode rather than hertz or shakes per second. So this is giving us shakes per minute, and it color codes anything that any of the numbers that are green there are engine speed related. And notice it gives us our engine speed, our vehicle speed, our tire RPM, and the results down below. We are getting a third order engine speed related vibration, which is exactly what we thought we would have. Okay, now Laura, step on the brake and put it in reverse. With the vehicle under a load, sometimes you'll get additional vibrations or even more amplitude from an existing vibration. Let's see if that changes anything here. No, we still have the third. Occasionally you'll see a second order engine vibration. V6 engines also have a second order vibration that might be load sensitive or torque sensitive. All right, let's go to bar graph. There's our engine third. Tiny bit of an engine one every once in a while. And then back to our vehicle view screen. All right, put it back in park. Now, I've had some comments of wanting to know how accurate this app is as far as measuring frequencies. So I'm going to switch. I'm going into the settings by clicking on the gear icon, and if we go down to units of measurement, click on vibration frequency and change from RPM to Hertz, and we go back. Let's now look at live data. We are getting approximately 29.7 hertz, 30 hertz vibration as this engine shakes 3 times per revolution of the crankshaft. Well, I've brought along a resonant reed tachometer. This is a really old school vibration analyzer, and all it does is shows us the vibration frequencies that it's detecting and how hard the little reed shakes up and down is the amplitude level. So I want you to notice that it is vibrating, and let me zoom in closer here. Scoot everything over. So I want you to see the reed right here at 30 hertz is shaking really bad. So this old school vibration analyzer or resonant reed tachometer is telling us that we have a 30 hertz vibration. Obviously you can see on the NVH app screen that it's picking up at 29.7 hertz vibration also. When I had it laying here by itself without me touching it, notice we have a little bit of a 20 hertz vibration there also that's coming and going. And you'll notice on the app that occasionally we get a second order engine vibration coming in, and 20 hertz would match second order vibration, because look at our engine speed. Right now engine speed is 10 hertz. So 20 hertz would be 2 shakes per revolution. 30 hertz would be 3 shakes per revolution. So that's a verification of the accuracy of the app and the sensors inside of the smartphone. All right, this is on a V6 engine, and the next one I want to show you is the same thing but on a 4-cylinder engine. So we'll pause right here and pick up on a 4-cylinder. Okay, we've got a 4-cylinder 2007 Dodge Caliber right here. A 4-cylinder engine will also have normal vibrations, but those vibrations are only going to be 2 shakes per revolution, since there are only 2 cylinders on the power stroke per revolution of a 4-cylinder. So if I set the app on, or the phone with the app running on the engine, we should pick up an engine vibration. So there it is, glowing red. If we switch to the bar graph, we should have a second order engine, the E2, which notice the E2 is certainly there. If we move the phone to the radiator support, notice it's either gone or it's there, but notice the amplitude level. The height of the bar graph is much, much smaller. So 4-cylinder engines are a little more shaky some of them are, than 6-cylinders or 8-cylinder engines. This could have a transfer path problem to where a motor mount, transmission mount, exhaust mount, etc. is transferring some of those normal engine vibrations into the passenger compartment. If we go to the live data view, we can see the frequencies and the amplitude levels. Notice the amplitude levels are just extremely low. Our engine speed right now is around 14 hertz. We just started it, so it's slowly warming up. If I switch that back to RPM, (854 RPM). Notice on the live vehicle view, it is just barely picking up a vibration. So this caliber has some normal engine vibrations that are being transferred into the radiator support, which means they could also be transferred into the passenger compartment. So if you put this app in on the dash or the floor or the steering wheel and you pick up this same normal engine vibration, then something is wrong. Gasoline engine vehicles should not have that happening. Now diesels, on the other hand, you're always going to feel a diesel shaking. However, the amplitude level should be greatly reduced. So if we look at this amplitude level, we're at like 0.03 here on the radiator support. If we put it right on the engine itself, it goes way up. 0.6, 0.7, 0.8, 0.9, 1.0. Really high amplitude level. So we are getting a significant decrease in the amplitude level as we go to the radiator support. So the motor mounts, trans mounts, exhaust mounts, they're doing some of their job, but still somewhere something is allowing those engine vibrations to be transferred. And the help file has a big list of things that can cause these normal engine vibrations to be transferred. It's not just motor mounts and so on. All right, now we are, as you can see, looking at the vehicle view screen, we are using the Bluetooth adapter on this to read engine RPM. But let me show you how this can still work without the Bluetooth adapter. If I go into settings and turn off the Bluetooth data link adapter, and if I turn off the estimated engine RPM, if I go back to our screen here and we go to the live graph or the live data screen, we have the ability to manually input engine RPM. There's this slider right here. So notice as I move the slider all the way over to the right, it goes clear up to 3,000 RPM and as low as 400. And you can change the minimum and maximum values in the settings. But we were at about 700 or so RPM on the tachometer. So let's set that on there. Notice now, telling the app that we're at 700 RPM, we're still picking up that same vibration on the bar graph. If we go to the vehicle view screen, we're still picking up the same vibration. The only difference here is now we had to manually tell the app what the engine RPM is rather than read it automatically through the Bluetooth data link connector. So that's a cool feature. As I said, you don't have to have the Bluetooth connector, but it sure makes it easier for engine speed related vibrations only. It'll have no impact at all on drive shaft speed related vibrations or tire speed related vibrations. So here's a normal 4-cylinder engine vibration, 2 shakes per revolution, high amplitude level. We move it over to the radiator support or somewhere inside the passenger compartment, and the vibration is either totally gone or significantly reduced. That's what we're looking for. All right, now let's take a look at a V8 engine. Okay, our next vehicle is a V8. So we've looked at a 6-cylinder, a V6, a 4-cylinder, and now we're at a V8. We have a 2015 GMC Sierra pickup truck with a 6.2 liter engine. It is sitting here idling at about 600 RPM. As you can see with the blue words for engine speed, we are using the Bluetooth data link connection, and this is a 4-wheel drive vehicle, so it has a different vehicle powertrain there. If I set this on the engine, as we've done on the 4-cylinder and the 6-cylinder, now notice the engine is glowing red in the NVH app, indicating that there's some sort of an engine vibration. The app will automatically tell us if we tell it to record the vibration. It'll tell us what type of an engine vibration it is, or we can go into the bar graph, the live graph, and notice it says it's an E4 vibration, engine 4th order. So this is an 8-cylinder engine, so it has 4 cylinders, basically just half the number of cylinders. 4 cylinders per revolution on the power stroke. Notice it's a fairly low amplitude vibration. If we go to live data, we can see it tells us 4th order engine vibration at a pretty low amplitude level. All right, now as we move this out to the radiator support, let's go back to our vehicle view. Notice the engine is not glowing red, indicating a vibration on the radiator support or anywhere else if we put it on the vehicle. There's nothing on the bar graph, and there's nothing in live data with the 3-axis inputs from the internal sensor. If we go to turn off the Bluetooth data link and turn off the estimated engine RPM, and we set our vehicle or our engine speed with our slider at approximately 600 RPM. Now if we move it back over to the engine, it may have slowed down just a little bit. Let me move the RPM down. There we go. So 4th order engine showing up. If we go to the bar graph, 4th order engine. If we go to our vehicle view screen, the engine is vibrating, all without a Bluetooth input. So we can use Bluetooth or the manual RPM slider to tell the app the engine RPM, and then it does the calculations based on the type of engine and the number of cylinders as to what is normal. And there's a whole bunch more to that. And as I said, there's a help file included in the app that tells you all about engine vibrations, which ones are normal, which ones are abnormal, why they're abnormal, and what to do about diagnosing and repairing those. Okay, that is a demonstration of diagnosing engine speed related vibrations as far as do they exist on the engine? Of course they do. And do they exist outside of the engine, which normally they should not? As I said, diesels a lot of time will, but the amplitude level should be significantly lower. All right, thank you for watching.